Look up at the night sky. On a clear night, you can see countless stars. Each star is a sun, like our own. Many of these stars have planets orbiting them. We call these planets exoplanets because they are outside of our own solar system. The universe is a vast and mysterious place. For centuries, humanity has gazed upon the stars and wondered about our place in the cosmos. Are we alone? Or are there other worlds out there, perhaps even teeming with life? For a long time, these questions were the stuff of science fiction. But in recent decades, astronomers have begun to discover thousands of exoplanets. These discoveries have revolutionized our understanding of the universe. They have shown us that our solar system is just one of countless planetary systems out there. The discovery of exoplanets has ignited our imaginations. It has given us a glimpse of the incredible diversity of worlds that may exist beyond our own. Among the thousands of exoplanets discovered so far, one stands out as particularly intriguing: Corot-7b. The search for exoplanets is a challenging one. These distant worlds are incredibly faint and difficult to detect. They are often lost in the glare of their host stars. But despite these challenges, astronomers have developed ingenious methods for finding exoplanets. One of these methods is called the transit method. This method relies on the fact that when a planet passes in front of its star, from our perspective, it causes a slight dip in the star's brightness. By carefully monitoring the brightness of stars over time, astronomers can detect these dips and infer the presence of planets. This transit method has been incredibly successful. It has been used to discover thousands of exoplanets, including Corot-7b. In 2009, a team of astronomers using the Corot convection, rotation, and planetary transits space telescope made an exciting discovery. They detected a tiny dip in the light of a star located nearly 500 light-years away. This dip, they realized, was caused by a planet passing in front of the star. This planet, which they named Corot-7b, was unlike anything they had ever seen before. It was a rocky world, like Earth, but it orbited incredibly close to its star. This close proximity meant that Corot-7b was subjected to intense heat and radiation, making it a truly alien world. Corot-7b is a super-Earth exoplanet. Larger than Earth, but smaller than Neptune, it orbits Corot-7, a star slightly smaller and cooler than our Sun. The planet is tidally locked. One side faces eternal day, the other perpetual darkness. The day side reaches 2,600 degrees Celsius, hot enough to melt rock, forming vast lava lakes. This creates a truly alien landscape. The atmosphere is mainly vaporized rock and metals. These elements could fall as a fiery downpour. Corot-7b is a fascinating subject for astronomers. Imagine trying to spot a firefly next to a blazing spotlight. That's the challenge astronomers face when searching for exoplanets. Planets are much fainter than their host stars, making them incredibly difficult to detect directly. One of their most successful tools is the transit method. If a planet orbits a star edge-on, it will occasionally pass in front, blocking a tiny fraction of its light. This dip in brightness is minuscule, often less than 1%, but even these tiny dips can be detected with sensitive telescopes. The transit method reveals crucial information about a planet's size and orbit. This method has revolutionized exoplanet hunting, allowing us to discover thousands of worlds beyond our solar system. In 2006, a new eye on the cosmos opened, the Corot, or Convection Rotation and Planetary Transit Space Telescope. Launched by the French Space Agency, with contributions from ESA, Austria, Belgium, Brazil, Germany, and Spain, Corot was specifically designed to hunt for exoplanets using the transit method. Unlike ground-based telescopes, which have to contend with the blurring effects of Earth's atmosphere, Corot-7b enjoyed a crystal-clear view of the cosmos from its perch high above our planet. This vantage point, combined with its sensitive instruments, allowed Corot to detect minute fluctuations in starlight, making it a powerful tool in the search for distant worlds. Corot-7b stared tirelessly at a fixed patch of sky, monitoring the brightness of over 140,000 stars with remarkable precision. Its primary mission was to find exoplanets, but it also made significant contributions to stellar seismology, studying the internal structure and oscillations of stars. Corot-7b's keen eye scanned the cosmos, patiently waiting for those telltale dips in starlight that signaled the presence of a planet passing in front of its host star. Little did astronomers know that Corot-7b was about to stumble upon a world that would challenge their understanding of planetary systems and ignite our imagination. In 2009, after years of meticulous data analysis, the Corot-7b team announced an extraordinary discovery. They had detected a tiny periodic dip in the light coming from a faint star located some 489 light-years away in the constellation Monoceros. This star, later catalogued as Corot-7, was about to become famous not for itself, but for the extraordinary world it harbored. The dips in starlight, occurring every 20 hours, hinted at the presence of a planet orbiting incredibly close to its star. This planet, designated Corot-7b, was unlike anything astronomers had ever seen. It was a rocky world, like Earth, but that's where the similarities ended. Corot-7b whipped around its star at a breakneck speed, completing an orbit in just 20 hours. This blisteringly short orbital period meant that Corot-7b was tidally locked to its star, with one side perpetually facing the searing heat and the other shrouded in eternal darkness. This discovery sent ripples of excitement through the astronomical community. Corot-7b was the first confirmed rocky exoplanet ever found, and its extreme nature promised to reveal new insights into the diversity of worlds beyond our solar system. The discovery of Corot-7b was a testament to the power of human ingenuity and the remarkable advancements in telescope technology. Finding a planet as small and as close to its star as Corot-7b was a remarkable feat, pushing the limits of what was thought possible. It required not only a sensitive space telescope like Corot-7b, but also sophisticated data analysis techniques to tease out the subtle signals from the noise. The transit method, once a theoretical concept, had proven its worth, ushering in a new era of exoplanet discovery. Corot-7b was a triumph for the transit method, demonstrating its ability to find even the most challenging exoplanets. This groundbreaking discovery paved the way for future missions like Kepler and TESS, which would go on to discover thousands more exoplanets, further expanding our understanding of the cosmos and our place within it. The discovery of Corot-7b was a watershed moment in exoplanet research. It showed us that rocky planets could exist in the most extreme environments imaginable, challenging our assumptions about planetary formation and habitability. Picture this: a planet so close to its star that its year is shorter than an Earth day. That's Corot-7b, a world of extremes where the very laws of nature seem to be pushed to their limits. This isn't your average planet. It's a super-Earth, meaning it's bigger than our home planet, but smaller than Neptune. But size is where the similarities end. Corot-7b whirls around its star at a distance of just 1.6 million miles, over 23 times closer than Mercury is to our Sun. This proximity turns Corot-7b into a scorching inferno. Imagine the hottest day you've ever experienced, then multiply that heat hundreds of times over. That's the kind of heat we're talking about on Corot-7b. The star's intense radiation bombards the planet, creating a truly alien environment, unlike anything we can imagine. But there's more to this extreme world than just its scorching temperatures. Its close dance with its star has also locked Corot-7b into a state of synchronous rotation, meaning one side of the planet always faces the star, while the other is shrouded in eternal darkness. This tidal locking creates a dramatic temperature difference between the two hemispheres, further adding to the planet's extreme nature. On the day side of Corot-7b, temperatures soar to a staggering 2,600 degrees Celsius. That's 4,700 degrees Fahrenheit. That's hotter than the surface of some stars. At these temperatures, rock doesn't just melt, it vaporizes. Instead of solid ground, Corot-7b's dayside is likely covered in vast oceans of molten lava, a scene straight out of a science fiction movie. The intense heat creates a truly alien landscape, where rivers of molten rock flow across the surface, glowing with an eerie, incandescent light. The atmosphere itself is a bizarre mix of vaporized rock and metals. Imagine a sky filled not with clouds of water vapor, but with clouds of vaporized silicon, sodium, and even iron. These metallic clouds would reflect the intense starlight, giving the planet a strange, shimmering appearance. And if you thought rain was bad on Earth, imagine molten rock droplets condensing in the atmosphere and falling like fiery hail. This unimaginable heat and bizarre atmospheric composition make Corot-7b a truly hostile world, a stark contrast to the life-friendly environment we enjoy on Earth. Corot-7b's extreme proximity to its star has a profound effect on the planet, far beyond just its scorching temperatures. The immense gravitational pull of the star stretches and squeezes the planet, creating intense tidal forces. These tidal forces are so powerful that they've locked Corot-7b into a state of synchronous rotation, much like our own moon is tidally locked to Earth. This means that one side of Corot-7b always faces its star, experiencing perpetual daylight, while the other side remains shrouded in eternal darkness. This tidal locking has dramatic consequences for the planet's environment. The constant bombardment of radiation on the day side creates a scorching inferno, while the night side remains a frigid wasteland. This extreme temperature difference between the two hemispheres could lead to powerful atmospheric winds, as hot air from the day side rushes to replace the cooler air on the night side. These winds could reach supersonic speeds, creating planet-wide storms unlike anything we've ever seen. Corot-7b's dance with its star is a delicate balance between gravity, heat, and motion, a testament to the powerful forces at play in the universe. Section 4. Unveiling the Invisible. Studying Corot-7b hundreds of light-years away presents unique challenges. We can't see its surface features directly. Instead, we rely on indirect methods. Spectroscopy helps identify chemical fingerprints in its atmosphere. This reveals its composition and processes. Astrometry measures a star's wobble from a planet's pull. Corot-7b's proximity creates a detectable wobble. This helps determine its mass and orbit. These methods paint a picture of this alien world. Corot-7b showcases human ingenuity and our quest to understand the universe. A surface of fire and stone. Imagine a world where the ground is a sea of molten rock. That's Corot-7b, a planet so close to its star that its surface is a perpetual inferno. Temperatures soar to 2,600 degrees Celsius, hot enough to melt rock into liquid magma. Vast lava lakes dominate the landscape, churning and bubbling with heat. Rivers of molten rock snake across the surface, carving channels through solidified lava. Even in this hellscape, there's a strange kind of beauty. The heat creates a kaleidoscope of colors in the molten rock. Section 2. Beneath the Molten Sky. The atmosphere of Corot-7b is as extreme as its surface. Instead of nitrogen and oxygen, this planet's air is a toxic cocktail of vaporized rock and metals. Imagine a sky filled with dense plumes of sodium, potassium, and iron vapor. These metallic clouds reflect intense starlight, giving the sky a shimmering appearance. As these metals rise and cool, they form droplets that rain molten iron onto the lava lakes below. Corot-7b is a world of stark contrasts, where scorching heat and frigid cold exist in an uneasy balance. The day side is a furnace where rock melts and metals vaporize, but the night side, shrouded in eternal darkness, tells a different story. Here, temperatures plummet to minus 220 degrees Celsius, freezing nitrogen into a solid. This temperature difference drives powerful winds that circle the planet at supersonic speeds. These winds create planet-wide storms, a testament to the raw power of nature. While the day side of Corot-7b is a fiery inferno, the night side is a realm of perpetual darkness and frigid cold. The extreme cold could allow for the accumulation of frozen gases, creating vast plains of solid nitrogen or glaciers of exotic ices. These frozen plains, reflecting faint starlight, contrast starkly with the fiery glow of the day side. The only light on this side would be occasional volcanic eruptions, creating momentary spectacles in the darkness. The night side of Corot-7b is a place of mystery and wonder, a testament to the diversity of worlds beyond our own. Corot-7b, with its extreme environment, is a treasure trove of information for scientists. By studying Corot-7b, we can learn about the limits of planetary environments. How close can a planet get to its star before its surface turns to molten rock? What kind of atmospheres can exist in such extreme conditions? It's like putting our theories about planetary science to the ultimate test. Corot-7b challenges our assumptions, expanding our view of the universe and its incredible diversity. Before Corot-7b, our understanding of rocky planets was based on Earth. We assumed rocky planets needed to be a certain distance from their star to be habitable. But Corot-7b, with its molten surface and vaporized metals, changed that picture. This discovery forced scientists to rethink their models of planetary formation and evolution. Corot-7b became a textbook example of how much we still have to learn about the universe. One of the biggest mysteries surrounding Corot-7b is how it got to be where it is. It's so close to its star that it's hard to imagine it forming in its current orbit. One theory is that Corot-7b formed farther out and migrated inward over time. Another theory suggests Corot-7b might be the remnant core of a much larger gas giant planet. Solving this puzzle will give us insights into the processes that shape planetary systems across the universe. By studying extreme worlds like Corot-7b, we're also gaining a better understanding of our own planet's history. The early solar system was chaotic, with planets forming, migrating, and colliding. It's possible that Earth experienced some of the same extreme conditions we see on Corot-7b today. By studying exoplanets, we're gaining a window into the past, a glimpse of what our solar system might have been like billions of years ago. Corot-7b reminds us that our planet is a special place, a delicate oasis in a vast and often hostile universe. Imagine trying to understand a distant country by only glimpsing its silhouette through a foggy window. That's the challenge astronomers face when studying exoplanets like Corot-7b. These distant worlds present us with tantalizing puzzles, their secrets hidden by vast distances. We can detect their presence, measure their size and mass, and infer some details about their atmospheres. But piecing together a complete picture requires ingenuity, patience, and cosmic detective work. Despite these challenges, astronomers are relentless in their pursuit of knowledge, developing new techniques to unravel the mysteries of these distant worlds. Detecting exoplanets like Corot-7b is like trying to hear a whisper in a hurricane. The signals we receive are incredibly faint, often drowned out by the brightness of their host stars. The transit method, while successful, has its limitations. It relies on a fortuitous alignment, where the planet's orbit must be perfectly aligned with our line of sight. This means many planets remain hidden from view, their orbits tilted just enough to prevent a transit. But astronomers are developing new techniques to overcome these limitations, constantly pushing the boundaries of what's detectable. While the transit method has revolutionized exoplanet hunting, it's just one tool in the astronomer's toolbox. To fully understand worlds like Corot-7b, we need to study their atmospheres, surfaces, and interactions with their host stars. One promising technique is radial velocity, or the Doppler wobble method. As a planet orbits its star, its gravity tugs on the star, causing it to wobble slightly. This wobble can be detected by observing the star's light shifts. By combining data from multiple methods, astronomers can piece together a more complete picture of an exoplanet. Despite the challenges, the quest to understand exoplanets like Corot-7b continues to drive innovation in astronomy. New telescopes, both on the ground and in space, are being designed with ever-increasing sensitivity and resolution. Adaptive optics systems are mitigating the blurring effects of Earth's atmosphere. Space-based observatories, like the James Webb Space Telescope, promise to revolutionize our view of the cosmos. These advancements bring us closer to understanding the nature of these distant worlds. Our journey to Corot-7b has been a testament to the power of human curiosity. It's a world that pushes the boundaries of our imagination, reminding us that the universe is full of surprises. Just a few decades ago, the idea of planets orbiting other stars was science fiction. Now, we've discovered thousands of these distant worlds, each more unique and intriguing than the last. Corot-7b is a reminder that our solar system is just a tiny sample of the vast cosmic tapestry. The discovery of Corot-7b and other exoplanets has ignited a new era of exploration. Among the fiery hellscapes and gas giants, astronomers are searching for worlds that might harbor life. We're looking for planets in the habitable zones of their stars, where liquid water can exist. The search for another Earth is daunting, like finding a single grain of sand on a vast beach. But the potential rewards are immeasurable. Finding evidence of life beyond Earth would be the most profound discovery in human history. The study of exoplanets like Corot-7b is more than just a scientific endeavor. It's a journey of self-discovery. As we learn more about these distant worlds, we gain a new perspective on our own planet. We see Earth with new eyes, appreciating its delicate balance and life-giving atmosphere. The study of exoplanets reminds us of the interconnectedness of all things. The atoms that make up our bodies were forged in the hearts of stars that exploded billions of years ago. As we explore the universe, let us do so with wonder and humility, remembering that we are part of a cosmic story still being written today.